I'd like to share with you our vision of tomorrow's big data universe, where we think things are headed, and also where we think we might fit in. So the first starting point is commodity hardware, which is going to be the underlying basis of all big data solutions. And by commodity hardware, we of course mean the x86 servers. And typically, the commodity hardware is made available to the upper layers via a converged infrastructure that consists of a layer that abstracts and allows sharing of the infrastructure, which comprises x86 servers, the network, and storage. In other words, a cloud. Now, what does this entire converged infrastructure mean in the context of big data? So the first thing that comes to mind with big data is there are many new sources, and all of these sources generate a huge amount of data every day. These sources could be click streams, social media, location-aware sensors, and so on and so forth. So the very first issue with big data is how is all this data going to be captured? And that's where NoSQL Hadoop solutions come in, since these were designed with exactly this in mind as the very first step, which is ingest and store. Ingest in this environment is nothing more than writing a file, and store is writing that file into a distributed, replicated file system. Now, another characteristic of both the new data coming in and the NoSQL environment is that both of them are tolerant of very loosely typed or loosely defined schema, or even completely schema-free. For example, you can download clickstream, web logs, machine logs, ingest and store them without worrying about the schema, which can be defined later on when the data is being parsed during processing. But this is not the end of the story for big data. This will allow you to capture and store, transform, and process this data. But there's an additional requirement of integrating this data with other structured data, either from the enterprise's operations during its history, from third-party credit bureaus, and many other such data sources where the data, unlike these newer data sources over here, are much more structured and have complex relationships between the tables in the schema. And this is where an SQL database would come in, and this is where XtremeData's product would play a role. So an SQL engine coupled to the NoSQL Hadoop environment allows new data to be integrated with structured data so that the enterprise can derive economic benefit from these new data sources and the existing data. Now, if you look at, in summary, if this is the big data universe that we see in the near future, what are the requirements of the SQL engine? We listed them over here, and let's go through them one by one. Number one is it has to be a shared nothing architecture so that it can operate in parallel and scale up. The scale up has to be linear, and it has to scale up to hundreds of nodes, hundreds of terabytes, up to petabytes. It should also enable rapid deployment on demand. It should sustain fast load and unload. And the last point is, in particular, to exchange data between these two domains, you need not just a load and unload kind of mechanism, but also, in our view, a streaming interface where data can be streamed in without keeping duplicate copies. Our product DBX meets or exceeds all of these requirements listed, and we offer a very high performance SQL engine at a very low TCO. Thank you.